So we are looking for the range of this. So first thing we're going to do is we're going to pull off these coefficients into a matrix. So what that's going to look like is it's going to be 4, 1, negative 2, negative 3, 2, 1, 1, negative 4, 6, 0, negative 9, and 9. And I just pulled those directly off from the equation. Finish up the matrix there. Okay. And then now we're going to row reduce. So the first thing that we're going to do is we're going to take we're going to do 1/4 of row 1. Okay, so then we're going to be left with 1/4, negative 1/2, and then negative 3/4, and then row 2 and row 3 stay the same. Okay, and then next up we're going to be working with row 3 and row 2. So row 3, we're going to subtract 6 row 1s, and then for row 2 we're going to subtract 2 row 1s. So we can get rid of this 2 and the 6 over here. So now that's going to look like, we're going to keep row 1 the same, so keep row 1 the same as that, so it'd be 1/4, negative 1/2, and negative 3/4. Okay, and then this is going to be 0, 1/2, because we're subtracting 2 row 1s, 2, and negative 5/2. And then this is going to be 0, negative 3/2, negative 6, and then 27/2. Okay. Next up, we're going to take 2 row 2, so we can turn this into a 1. So we're going to keep row 1 and row 3 the same. So we're going to keep that 1, 1/4, negative 1/2, and negative 3/4. And then we're going to make this 0, 1, 4, negative 5, and then this is 0, negative 3/2, negative 6, and then 27/2, like so. Okay. And next we're going to be working with row 3, so that we can try to get some zeros over here. So we're going to do row 3 equals row 3 plus 3/2 row 2. Okay. So we're going to keep row 1 and row 2 the same, so it's going to be 1, 1/4, negative 1/2, negative 3/4, 0, 1, 4, negative 5, and that's going to be 0, 0, 0, 6. Okay, we just did 3/2 of that. So we got a bunch of zeros here now. Now we're going to work with row 3 again. We're going to take 1/6 row 3, so we can turn this into a 1. Again, we're going to keep everything else the same. Okay. Now, next we're going to be working with both row 1 and row 2. So we're going to take row 1 equals row 1 plus 3/4 row 3, and row 2 is row 2 plus 5 row 3. Okay, and then what that's going to look like, that's going to be 1, 1/4, negative 1/2, 0, 0, 1, 4, 0, and then we're going to keep row 3 the same. Okay, and then next, you can see that we are almost at a row reduced form. We just kind of have to get rid of like this 1/4 right here. So what we're going to do is we're going to take row 1, and we're going to be able to get rid of that by taking negative 1/4 of row 2. Row 1 minus 1/4 of row 2, like that. And so that's going to be 1, 0, negative 3/2, 0, 0. That's going to be we're just keeping the same row 2 and row 3. Okay. So now here we have, this is our complete row reduced form right here. So next what we're going to be doing is we're going to find the pivotal columns, okay? So the pivotal columns are the ones that have leading ones in them, right? This one, and this one. These are the 3 leading ones. And the reason for that is just because they go diagonally left to right, and they go down and to the right, and they don't necessarily have to go down and to the right like the next column, as long as they just go eventually down and to the right, and they do, and they don't have any other non-zero numbers in the columns. So here we have these 3, and so then next what we're going to do is we're going to pull that off of our original matrix. Our original matrix is right here that we got from these equations. Here's our original matrix, and here it's column 1, column 2, and column 4. We're just pulling it directly off this. So here it's column 1, column 2, and column 4. Just gonna pull it directly off. Okay? This is to write a vector equation. So to write the vector equation, okay, it's gonna be x1 times 426 plus x2 times 110 plus x4, -3, -4, and 9. And again, we got that because we just pulled it directly off of this original matrix from the original problem. Okay, so here is our vector equation. And now, to describe it geometrically, what we'd say is because there's 3 of these, and it's an R3, we'd say that it spans all of R3. Because there's 3 pivotal columns, and it's an R3, so it spans all of R3. And that's how you do the problem. Thank you.